This is year 2 A-level, and it's a differential equation where the variables are separable. And we've got to solve this differential equation giving the answer in the form y equals a function of x. Now the first step here is to basically separate the variables. So all the x terms on one side, all the y terms on the other. I'm going to start by factorising out the x from the right hand side. So my starting point would be this, 1 plus x squared dy by dx. Okay, and that would be equal to x bracket 1 minus y squared. Okay, now what I need to do is move the x terms to the right, the y terms to the left, and separate the dy and the dx. So the next step from there, if you're careful, you should be able to do that in one go. I would put 1 over 1 minus y squared and that would be with the dy, and I'm going to put the integral signs in a moment because writing that on its own doesn't really mean anything. Okay, but for now I'll just leave it like that, and on the other side I've got x over 1 plus x squared, like this. Okay, x over 1 plus x squared. Okay, and that's dx. Okay, so at that point, those two statements just enable you to separate the two variables, but without the integral sign in front. They don't mean a lot, but they do now. Okay. Now you should be looking at these and thinking, how are we going to integrate these? Well, the one on the right, you should notice the x one has a derivative, or a multiple of the derivative of the denominator is found on the numerator. Okay, so we've got this x here, which is a multiple of 2x, which is the derivative of the denominator, so that's a log. This one will be 2 logs once we've recognised that 1 minus y squared is the difference of 2 squares, and in fact this can be written as 1 over 1 minus y times 1 over 1 plus y, which we then put into partial fractions. I'll do that over here. Okay, so this is separating out the partial fractions. So we're going to say that we want 1 over 1 minus y squared. Okay, and that's got to be equal to a over 1 minus y and b over 1 plus y. And we then got to set out to find what a and b are. Okay, so just be very careful here with minus signs and so on. So I'm going to put a plus sign between those two because we don't know what a and b are at this stage. And remember that a and b may be integers or they may be fractions. So let's solve that and find out what they are. So we know therefore that a times 1 plus y, okay, plus b times 1 minus y must simply equal 1. Now you can go a little bit further with this, but you should be able to see quite quickly from there that a plus b is 1. What I'm really doing here is equating coefficients, you see. So a plus b are both numbers that add up to 1, and ay plus b times minus y, in other words, a minus b times y is 0. In other words, a minus b is 0. Okay, and it's very easy to see from that I'll just put a comma there, a and b are both therefore equal to 1/2. Okay, so using that, I can now go back to here and I can say that my integral is equal to the integral of, well, I'll put the half outside, okay, because it's common to both of these. All right, so I've got a half of, and it's going to be 1 over 1 minus y plus 1 over 1 plus y, and also, and that's dy, now really I want the integral sign there at this stage. Let me just put the fractions in as well. Okay, so that's that, and that's that. Now, strictly speaking, because there's two terms, I'll leave the bracket in actually, because it's better to do that when you're integrating two terms. So if I just close that bracket off, what I really want to do is put an integral sign in front of that bracket, like that. Okay, and I know that that is therefore equal to the integral of this, which is, I'll just leave it as it is for the moment, x over 1 plus x squared dx. Okay, so now at the next step we will go through and integrate throughout. So let's go with that, and we should recognize that we have here, we've got this common factor of a half. Okay, I'll put this here should be an equal sign, and that should be an sort of an arrow sign really there. Implies like that. Okay, so the next step would be a half of the natural log of, now it's going to be the derivative of 1 minus y is minus 1, so it's going to be minus log of 1 minus y. We should put our modulus signs in, and then it's going to be plus log 1 plus y, and that's going to equal, now it's going to be half of, because the derivative of x squared is 2x and we've only got 1x there on the numerator, so it's a half of the natural log of 1 plus x squared. Okay, now we should add a constant of integration there to one side or the other. Now, because I have a common half, what I'm actually going to do here, it's okay to do this at this stage. I'm going to put, because I want to take out the common factor of a half, I'm going to put a half c as well. So c is just a number. Okay, so I'm just going to call it a half c, because then I can take out a common factor of a half throughout the whole thing, and I can write the c as log k. All right, because then I'm going to have be able to make a single log expression for both sides. So the half has gone. This expression here is the same as log of 1 plus y divided by 1 minus y. So I can now say I've got the log of 1 plus y over 1 minus y. Okay, using the rules of logarithms because of the minus in front of this log here. Okay, now again I should have those modulus lines in there, and that is going to equal, Now, what I can do here, I've taken out this half, and I'm going to rewrite this c as log k. So it's going to be the natural log of k times, okay, I'm jumping a step here possibly, but basically if c is log k, then if I'm adding log of something plus log of k, it's the log of k times that thing there. So it's the log of k times 1 plus x squared. So it's that. Okay. And because I've now got a log on each side, I can take it out. And that's obviously what I've been aiming to try to do all along. So now I've got to that stage, I can say that 1 plus x over 1 plus y over 1 minus y, 1 plus y over 1 minus y is equal to k times 1 plus x squared. Now, we can use the boundary conditions now. We're told in the question that when y is 2, x is 0. Okay, so x equals 0, y equals 2 implies that, well, we've got 1 plus 2 is 3, 1 minus 2 is minus 1, minus 3 equals k times 1 plus 0, minus 3 equals k. Okay, so k is minus 3. And so the next thing we need to do is go to this side here. Okay, and we just need to finish this off by replacing k with its value. So here we go. So we have 1 plus y, and I'm going to multiply both sides now by 1 minus y. So 1 plus y equals minus 3 times 1 minus y. I've just brought that denominator up to the right, times 1 plus x squared. So all I've got to do now is carefully get y on its own on one side. Okay, so if we expand this out, we've got 1 plus y, 1 plus y. That's going to equal minus 3 times 1 plus x squared. So I've got 1 plus x squared minus y, and I've also got minus yx squared. Okay, if I put multiply out the brackets, probably the best thing. 1 plus y equals minus 3 minus 3x squared plus 3y, and we've also got plus 3yx squared. Okay, now we just move all the y terms to the left and all the non-y terms to the right. So I've got a y, I've got to take that 1 over the other side, but let me first of all bring the minus 3y and the minus 3yx squared. Okay, so all the y terms are on the left. Then I've got my 1 to bring over, so it's now minus 4. Okay, I've got my minus 3x squared there, and the other two terms were both y terms which moved. So I've now got all my y terms on the left, 3 of them. So if I just factorize out the y, well, I've got y minus 3y, that's minus 2y minus 3yx squared. So it's y brackets minus 2 minus 3x squared on the left. And on the right, I've just got minus 4 minus 3x squared. Okay, now everything is negative on all four of those terms, because I'm going to put that bracket underneath here. So I can simply say from here that y is the negative of 4 minus 3x squared, and underneath that I've got minus 2 minus 3x squared. And because everything's negative, if I multiply the numerator and denominator of that fraction by minus 1, then simply I have that y equals 4 plus 3x squared. Okay, and that's over 2 plus 3x squared. Okay, now you could have variations of that, I'm sure, but that answers the question by providing y as a function of x, but they'll accept equivalent functions that are reasonably simplified. Okay, and that's it.